It is time for Daniel to start his presentation. Afonso, please join us. Have a seat. You can carry on, enjoy your pizza, but we are about to start. It's fine. The pizza's going to be there. It's not going to go away. We have the rest of the evening to network. So, ándale, ándale. Bon, everybody, it's time to start.
Okay. Is everyone well in the back? Cool. Okay, so we're ready to start. Let's just give a couple minutes for that person in the back to sit. Okay, cool. So we're all ready. Thanks everyone for joining us today. I hope you've been enjoying GreeceJS. The ones of you who attended GreeceJS, I hope you're having fun so far. I really liked the last Kahoot. It was a bit tricky for me, a couple of them, but oh well. So once again, thank you for having me, and let's start this thing. There are three things that I really hate as a developer. And the first one starts with unmaintainable code. So this is kind of code that the more you add to it, the worse it gets. And then you're just living in hell because everything is tricky. Then the second thing I hate is when that unmaintainability now finds a way to crawl inside from your code going into your tests. And the third one is actually when a task arrives late during a sprint. So what does this mean? Let's picture for a scenario that there are two parts of your team. One that starts with a task, and the responsibility that you're going to have afterwards is to get that task and finish it. Now, the issue here is that the other person takes 98% of the time, and then you only have 2% to finish it. So what happens after? Then your project manager is going to get pissed. He's going to start complaining to you, and you have 20 minutes to finish everything and ship it to production by yesterday. And I could rant about this for years, but we have a talk to give. So let's continue here. I can tell you something, and that something is very cool, is that I fixed these three issues. All of them are gone now. How did I do it? Well, it's time to tell you a story. And like every good story, we start at the middle. So me and my team had just defeated the unmaintainability monster. So now everything was okay. Because what was causing the unmaintainability in our code? Heck, server state. And as some of you might know, server state have many, many challenges. There are stuff like caching, lazy loading, offline support, managing outdated data, and these type of things, well, are terrible. And the issue that we were having is that we were kind of implementing our code to fix these things, and it was terrible. The more code we added into it, the worse it got. We were adding features for caching, we added features for optimistic updates, paginated data, it was terrible. So in a bit, we started thinking. See, okay, wrong button. So we started thinking for a bit because, okay, why are we implementing all of these things by ourselves? We're kind of just making our code worse and worse and worse the more features we added into it. Didn't anyone out there thought about something that would fix this? And this is the part of the story where the hero finds the solution. And in this scenario, it's like, I don't know if you ever watched that movie, which I forgot the name now, but there's the King Arthur there and he has the Excalibur. Like, that's the part that happened to us, because there was a coworker that one day got into the room and said, I found our Excalibur. And he put 10-stack query out of the stone for us, and we started using it everywhere. And thanks to 10-stack query, we ended up deleting all of the features that we were implementing ourselves and just kind of rolled with it. And it saved us a bunch of time with our code. And this was how we beat the unmaintainability on our code. But wait. Okay, but as every story happens, when the first issue is overcome, there's a new threat working in our shadows. And in this scenario, what happened was, as soon as the unmaintainability of the code got better, it found a way to crawl into something different. It found a way to crawl into our tests. So a new threat worked in the shadows, and in this scenario, in our tests. And I don't know if you remember what happened in this scene, or if you ever watched this movie. This is Hercules, and when you know what happens when you cut a Hydra's head? Exactly, two more take its place. And this was what happened with us, because now we were not maintaining the stuff that we fixed with 10-stack query, but our tests were terrible. And our tests now were well, they were unmaintainable, they were flaky, and they were super, super complex. And we found many, many solutions to deal with it. And that's a bit what we'll be talking throughout this presentation. Because it was super fun the way we found out how to fix this. And yeah, after like 3 years by now, which was when this story happened, I can safely tell you that we fixed all the 3 issues that were bothering me in the beginning of this presentation so far. And the fun thing, well, the fun thing was that all we needed was a contract. So thank you so much for having me. Let's start the presentation. For those of you who don't know me, I'm the person on the left on this photo. The other one is my junior rubber duck programmer, whatever. I'm a developer advocate at OLX. I'm an EGED.io instructor, Altiero ambassador, and the author of the just released book, State Management with React Query. So if you like React Query and Stack Query, depending on how you call it now, this book has like all my knowledge of it, which I've been using like for 3-4 years, and it has a couple of things that are coming in the next version. So I'm super excited for it. So now I want to get back into the story because this was what was happening to us. Let me just change the microphone. So what happens typically when you want to get the data? So you have your browser, and then your browser does a request to the internet, and the internet sends you back the data. Now, this happens typically in an application, but now if you're talking about your tests, wait, the clicker, okay. So when you're talking about your tests, especially in unit and integration tests, you don't want this to happen. So you have to find a different way to deal with this. Okay, the clicker is taking a bit to process. Let's try again. Okay, so we had to find a solution to fix this. We didn't want our tests to be doing the actual request because if you're going into the internet, you're getting the data, you end up with, well, different data every time you do a request probably, so we need some mock data out there. So we kind of went with one approach in the beginning. I'm already spoiling. So we started with doing manual mocks. So we were kind of just replacing the implementation of the features that we had that were responsible for getting that data into our tests. And this worked for a bit. Then we changed from GraphQL to REST, but we still had some GraphQL stuff there. And now we were maintaining this, but we also had Axios mock adapter there to deal with the Axios stuff because we were using Axios as a client. And I swear to God that at a certain point, there was even magic there. I have no idea what that code was doing, but it was something that was fixing and was allowing us to get mock data into our tests. Now, this has a caveat, which is whenever we change our manual mocks, it would break our mock adapter implementations. Whenever we change the mock adapter implementations, well, you guessed it. And if the clicker lets me, you'll guess it again. Oh. Uh-oh. Okay. Yeah, it broke the magic. And whenever we fix the magic, it would break the manual mocks. So you could probably imagine the stress that it was for us to deal with this type of things because it was complete chaos. Everything was terrible. We were in fire and we hated it. We needed something different. We needed a way to avoid all this magic and all this other crap that we had in our tests. And we thought about it because there was a couple of things that we were using to prepare for development. So one of the things that we had was a contract. So contracts were the things that allowed us to specify what the API was going to be like, what was the schema for it. And for it, we would go into the contract and say, we have this route, and this route data is going to follow this schema. And we thought, what if we could use our contract by looking at it and just, okay, now we already have defined the routes and everything that we're going to have in our code. So why not use it, really? And we said, okay, we need to find a way to deal with this implementation. We need something that allows us to get out of all the other 3 implementations and go with this thing. And this was when we got to know something called mock service worker. So, and here is going to be a cool animation if it works. Yeah, because that's the brightness of it. It was shining on our code thanks to it. So I want you to forget the story for a bit, and let's review how mock service worker works before we get back into it. Oh, okay. So mock service worker is an API mocking library, and it uses service workers to pretty much intercept your actual request. So how does this work? Well, traditionally, like we saw in the beginning, you have your browser goes into the internet, it gives the data back, and you show it in your application. Mock service worker adds a service worker in the midst of it. So whenever there's a request that is fired by your application, service worker is going to intercept its request. It's going to ask itself, do I have this data mocked here somewhere by following the contract? And it's going to return that data back to your browser. Now you might be asking, okay, but what if you don't have that contract, or if you're trying to go to a route that doesn't exist? Well, it still works, because if it's a route that is not defined on it, it will send it right straight to the internet and return the data back to it. So, okay. Now, there are two fundamentals that you need to understand mock service worker. It's request handlers and response resolvers. And once you know this, you can use mock service worker everywhere, and you can go home and start implementing this. But go home after the talks, please. So, starting with the request handlers. Request handlers are the things which allows you to specify the contract for the data that you need. So, it works for REST and it works for GraphQL. So in this scenario that you're seeing here, we are telling mock service, we're going to be creating some request handlers that are going to be responsible for. Whenever there's a GET request for Daniel JC phones, it's going to return our response resolver. The response resolver, which is the second thing that we're going to see after. But just so you know, it also works with GraphQL, so you can define it. So whenever there's a query in this scenario, the GET users query, you can also have a response resolver to return the data that you need. Now, looking into the response resolver part, the response resolver in this scenario is the part that you can see inside of the request handler. In this case, we have an arrow function. It receives three parameters: the request, the actual request that mock service worker intercepts, the response, which you can use, well, to send your response, and the context, which is a bunch of utilities. So in this scenario, as you can see, whenever there's a GET request to Daniel JC phones, we're going to return a response, which is a JSON object, which on the first name has John, and on the first name property has John, and on the age property has 38. And that's pretty much it. That's pretty much how handlers work. This is the fundamental part of it. Now, how do you make this work? How do you configure the service worker? Or if you want, you can also use this in node environments, but on this scenario, it's not going to be a service worker. It's going to be a node interceptor package, because you don't have service workers running up there. So how does this work to set up? Let's look at the browser process. It starts by using the setup worker function. So how do we define this? Not like this, wait. Let's go a couple of slides back. Oh, okay. So this is how you actually define it. You pass all your request handlers to your setup worker function. This function receives these things, configures all its internals for you, and it gives you back your worker that then in your code, all you have to do is go down there and start it. So worker.start, and you run your code. The service worker starts automatically, and it starts intercepting all of the things that you might need. Now, how does this work in practice? I'll show you a bit of code, but let me just show you this part. So whenever there's a GET request in this scenario for Daniel JC phones, which was a thing that we had configured up there, the service worker is going to do something. And this thing is ask itself, do I have a defined handler? Does anything that I have respect the contract? So whenever there's a GET to Daniel JC phones, do I have anything defined? And it's going to work into its inside of it, to its request handlers, and it's going to say, yes, I do. And what should I send it? Should I send it back? In this scenario, nothing. Oh, wait, it's going to work. Okay, it worked. And we're going to return it an object with the first name and the last name property, because it was what was defined on the slides we saw previously. Now, the question we asked previously, what if a route that we don't have defined in our handlers comes up? Well, this is when you go into that process that I mentioned previously. So we have a GET request to random. Mock service worker is going to ask itself, do I have any defined handler? And it's going to tell you, no, you don't. There's nothing configured here. So what is he going to do? He's going to allow that request to go to the internet. He does the actual request, he gets the data back, and it sends it back to your application so you can use it. And that's pretty much it. So what was the process that we followed to save our tests, to get rid of all that stuff that we had? Well, we started by deleting all the mocks. We got rid of all the manual mocks, all the Axios mocks, all the magic, all that crap. Everything was gone now. The second step, we looked into our contract that we have defined with our backend team, and we created all the handlers that we needed in our code. And the third thing, we started the server right before the tests. And this is talking about the tests. So I just shifted the presentation back into the story again. So this is pretty much the process of how we got rid of all the unmaintainability that we had in our tests, because now all we needed was MSW up there. We did the actual request on our tests, MSW intercepted, send the data back, and we didn't have to worry about mocking stuff, because that's one issue when you mock stuff. You get rid of the actual implementation. So in that process, we might have forgot some bugs or some issues because we're not using the actual implementations of the functionalities that we had to run our tests. And for a moment, everything was better. It was peaceful, because now we had 10-stack query for dealing with the issues that we had with server state. We had mock service worker to fix the testing issues that we have, because now, okay, we just had to define the contract for our tests, let the data go out there, intercept it, send the data back, and our tests were good again. But remember, I told you there are 3 things that really annoy me as a developer. And if you don't remember, it was the task arriving late during the sprint. So I'm going to try very hard to not go into another rant here, but this was what happened. So traditionally, we had a 2-week sprint. And there were 2 parts of our team. We had the back-end team and we had the front-end team. At the time, I was on the front-end team. And what happened was, the purpose of this sprint was pretty much to, okay, during this sprint, we're going to build the API, and the front-end is going to be consuming it and displaying the data. And the way that we were doing it, and I'm not going to say it was the best way, because it wasn't, but the way it happened was, first, let's see if it clicks. Okay, the backend started working on the task. So the backend was building the API, was building the contract, and building everything so that us as a front end, once that was finished, we could use it. And whilst that was happening, us as front enders were working on different tasks. Let's click on it. Okay, but if you notice, the arrow still hasn't finished. There's a bit there that is a space. There's a space there. There's this little space that we see here. Now, what is this space, you might ask? Is the time we had to save the sprint. Remember those 2%? That was it. And this thing was the thing that was ruining the team relationship, because we were stressing. Our product manager was pushing us. We had to deliver stuff. And who did we blame? We blamed the guys who took 98% of the time to build the API, which we shouldn't have been doing at first place. But, well, there are dysfunctions in teams sometimes. And we had this time. This was our 20 minutes that we had to save the sprint. We had to figure it out somehow. But yeah, then we started thinking, but wait, remember that thing we started using for our tests? Doesn't that run on the browser? And someone said, oh, wait, it does. So what should we do about it? Well, what if, here's a wild theory, what if we pick up the contract we have for it and we start running mock service worker on the browser as well? Like, okay, but why? Because now you don't need the API. You can start running this thing the same time. You can pair work, and you can guarantee that you finish your sprint on time. We said, okay, let's give it a try. And we changed the process. So now what happened was, right before the sprint, we had a meeting. All the team got together, and we defined the contract beforehand. So there was no more backend defining the contract alone. They defined the contract together, and they said, okay, we need this, we're going to need that, we're going to have this. So when the sprint started, we already know everything, all the routes, all the data, the schema of all the data that we're going to have. What did this mean? It meant that we could start doing the same work at the same time. And one thing that actually ended up being funny is, because we already stressed previously, we're already usually working with Trauma to deliver stuff faster. We ended up delivering stuff faster as well, as you can see. So when the backend had finished working on the API, we had already built the thing that we needed, because, well, we had mock service worker intercepting the requests on the browser in development. So this means we didn't needed the API, because, okay, we have all the data that we're going to need. Okay, I forgot to breathe. And then, yeah, it even really helped the team have more time, because now we could do other tasks after we finished the main one. We could focus on other things. And as you can see, the sprint, everything still ended up on time. There was no more hard feelings between the different parts of the team. Everyone was happy because, well, we're delivering stuff on time. The product manager was happy. The users were happy because features were actually being delivered right on time. Like, it was amazing. There's actually a video of us celebrating like the sprint after, but I'm going to show it to you in a bit, because let's just recap the 3 steps that we had to follow. So the first one was define the contract. Now we have the contract that defined all the routes, and we know the schema for the API. So with that, we were able to create all the handlers. And then the third step, start the service worker on the browser. And that was simple as that, because now, thanks to these 3 simple steps, we were able to get our team into this mood, because now everyone was happy. Everything was going right on time. And now this is the part where I'm going to try to show you some code, which I already pre-built because I'm not crazy to do a live demo right now. So I'm going to try to sit, just so I'm able to show you this. Let's see what we have here. Okay. Can you all see the code well? Yes? Okay, cool. So here we have an application that's already pre-built, which I'm using as a material for a different thing. But the way this works, let's see if I can click on here. Oh, wait, I need to start it first, probably. So what happens here? Let's show this code. This is a very simple application with terrible CSS, because I'm terrible at CSS, which is responsible for just pretty much is a place where you can add cars, where you can have a list of cars. It's just a funny thing to build for a simple project. And here, as you can see, or you should be able to see, we have our car information where you have a photo, a bunch of stuff, and whatever. Now, how does this work actually? Because you don't know, but mock service worker is already responsible for intercepting every request that's happening on this application. So the way this thing works is we have our code, and we started by defining our handlers. Our handlers are according to our API, which we based on our contract, but here we have defined everything that we need. So whenever there's a post request or this route, post request for this route, a get, a post, a delete, whatever, all the rest stuff that we need. So what we had to do here was go create an handlers file, and this handler file does a couple of things. So we know that we are only using REST, so we destructure REST for MSW, and then we create our handlers array. So remember request handlers, this is what we are doing here. And these handlers are doing a couple of things. So whenever there's a post request to a route that includes cars login, we're just going to return this JSON object. The same thing for all of these things, because that's all I need to do in this application. But there's limitless possibilities. For instance, let's imagine that you needed to do the actual request, get the data, and then transform it somehow for doing magic or whatever. This is not a scenario that I've used personally, but let's see if I have it here already hard-coded to save you a bunch of time. Let's see. If we want, we could actually use the context, and this context allows you to do the actual request, and once you get the actual request data, you can transform it somehow and use it in your application to do whatever you want. This is just on scenarios that you want to try some different things, or when, for instance, it is useful when you already have an API, something built, and you want to add a feature. So when your team is adding that feature, you can do some transformations extra to try this thing out. And yeah, we have our handlers, and then all we had to do is define our service worker. We send an array to the setup worker. This returns the worker, and then all we had to do is start that worker. And now if we go back to the browser, let's see this thing try to work here. Let's see if this works, because I can see anything here. Let's see if I'm able to see the stuff here. Okay. Because for some reason the button stopped working for me. There it is. And I don't know the shortcut for the developer tools right now. I'm feeling ashamed of myself, but that's the spotlight effect. So let's see if I'm able to show you these things with a very, very small. Let me resize this stuff. Oh, yeah, that I can do, definitely. That works. Thank you. So now if I do a refresh here, first you're going to see on our console a bunch of errors, but that's a different thing. That MSW is going to tell you, okay, mocking is enabled, so your service worker is running. So if we go into the network tab now, and there's a specific request that I want here to show you, which should be, let's see, it's this one. Yeah, it's this one. So as you can see, we are doing a GET request to get this data. It's giving us a response. But if you look at the status code, I hope it's able to see there. Yeah, so you see 200 OK, and it says from service worker. And what service worker? Yeah, it's powered by mock service worker. So this is pretty much the interception process of how it works. And it just works with everything on your application. And it also runs, let's see, in your tests, because besides configuring a worker by using the setup worker stuff, we also set up a server. So I remind you all that this is not a service worker. This is a node interceptor package, which is pretty much responsible for whenever it detects there's a request in a node environment, it's going to mock it out in this scenario and send the endless data. So if I show you our test examples, there's nothing mocked out here, no weird things, no whatever, because all we had to do is in our setup tests before we start them, we tell mock service worker, hey, I want your server to start intercepting stuff. So whenever a test runs, every every request that is done is going to be intercepted by mock service worker. There's just one thing that people like to ask, which is, okay, but what if there's a scenario that I don't want to use any of the handlers that you have and I just want to overwrite something? Well, you can actually do that. You can tell mock service worker, in this scenario, you have access to your server instance, and tell it, okay, for this specific test, I want you to override all your handlers with this one specific that I'm giving you. And this is the way that you can even do mock implementation for error scenarios or whatever. So there's a bunch of patterns and stuff that you can use for it. So to finish the presentation, which I don't know how much time I've been going through, but we're at the end, I promise. Let me stand up. Let's see if this works. Okay. So as you can see, I got rid of all the 3 issues that we have, and mock service worker ended up being the solution for 2 of them. But that's not it. If I want you to leave this presentation with a message and with something to take home, is that our goal as engineers is to deliver amazing things to our users. And what does this mean? What am I trying to say with this? Because, well, obviously we're working on products. We want to deliver stuff for users. And when do our users want those things? Typically for yesterday. So it's on these scenarios that we have to focus and try to avoid going into the DIY, the do-it-yourself, or into the over-engineering aspect. Because this was the thing that messed up with my team, that screwed us, because we were implementing a bunch of stuff by ourselves. We thought, okay, no, we can do it. We're going to implement stuff. We're going to do these things ourselves. But you know what happened at the end? Well, we ended up having to maintain a bunch of extra code, fix the bugs, and yeah, cost a bunch of development time to our team. Instead, what we should have done right at the start is think, okay, probably we're not the only ones having the same issue. Probably there's someone out there that already had the same issue. Well, probably someone even created an open source package to deal with it. And probably that open source package is already used by millions. It's maintained, is updated, is tested, and has all the community support. And that should be the thing that we should have started for first. We should have avoided DIY, we should have avoided over-engineering, and thought about, okay, let's see what it already exists. And this was pretty much the thing that caused the downfall and started the issues that we had with our team. So, all of this to say what? Let's just click here. All of this to say what? Think about open source. Think about the package that already exists. Because likely, like I said, someone might have already had the same issue. If I had known 10 stack query earlier, I would have probably saved like 3-4 months of development to my team when we were implementing all of the things by ourselves to deal with server state. And if I had known mock service worker, I would probably have saved 2 or 3 or 4 weeks, whatever, because we would not have to deal with all the stuff that we had in our tests. Really, mock service worker probably became the thing that I've added to all my applications recently, because, well, I'm a lazy person sometimes and I don't want to build APIs, so I just define a contract and I have these things. And in production, when I'm doing in my teams and teams that I'm working on, it speeds up our delivery process. It speeds up our time. It makes our users happy because now we're giving stuff to them faster than they wanted them. And it's really fun because thinking about all of it, thinking about all the process that we had, all we needed was a contract. And really, that's super amazing. So once again, thank you so much, CityJS. Thank you so much, GreeceJS, for organizing this event. Thank you for having me. Yeah, I'm Daniel Afonso. Thanks.
Everybody, we do have 5 minutes for questions.
Okay.
So do we have any questions for Daniel? Anybody?
you don't have questions, I'm gonna eat pizza. But
We have one
questions.
question.
Woohoo!
Pizza
Tell
is
me.
gonna wait for.
I'm sorry about the pizza.
No problem. We can eat pizza together after.
Okay. Thank you for the talk. Very
Thank you for
interesting.
joining.
I think lots of people related, especially with the back-end front-end struggle to sync the two jobs and have to do things at the end of the sprint. I want to ask, have you, as from your screenshot, I figured out that you're using Swagger for the contracts, correct? Swagger also has a lot of automations with relates to tests and mocking. Did you try out any of those? Because we're using one and we're pretty happy.
I have a fun story with that, which was I had a coworker which was actually trying out to integrate with Swagger and generate all the contracts that would generate all the JavaScript stuff automatically to our application. So he pretty much was automating the part of bringing it from Swagger to Endless. But then he left the company and no one picked up on it. So that's the thing. In production, I ended up not having more scenarios to do it. And unfortunately, now I'm not shipping code to production every day. So I haven't tried it. But yeah, that's a very good idea. And probably, I don't know if you check mock service worker documentation and stuff like that. See if there's an integration up there to do stuff like that.
From our experience, you don't need the mock service thing.
Okay,
because
amazing.
This can set up a standalone server which mocks everything. So essentially, instead of hitting your API, you hit this thing. And this thing can either hit your API, or if your API declares that this is not implemented yet, it can return a mock response based on the examples from the contract. So if the contracts are well set, it can work like this. We can talk after.
We can talk about definitely, but I want to try that thing out because it seems like it's even more time saver.
There you go.
Anyone
Any other questions for Daniel? Sorry, Daniel.
Yeah.
Hi. I would like to ask, what's the advantage of using a service worker compared to having, for example, a separate server returning mock data, and then you change your app to hit that? Yeah.
So for that, I have a question, not a question, but something that I've pretty much, it's the selling point for everyone, which is all this work that and all the code that I show, I only had to do npm install and have the endless define and start the server. So I didn't have to configure the server. I didn't have to configure all those things. So this is the process of, okay, I could build a server. I could build an integration server or test server, whatever that's running in a different point. But in this thing, first, you have it local in your application. If it's local in your application, it intercepts all the stuff right there instead of actually going into the outside server or asking the request. But yeah, I would say that the main point here and the main benefit is pretty much zero configuration and saving the time of building and maintaining a dev server apart. I don't know. I hope I answered your question. Okay, thank you. Hey, go ahead. Is it a microphone? Just so people at home can hear you.
Thank you. I don't mean to be the guy who asks the difficult question.
Oh no, shoot them. Go ahead.
I'm not trying to make it difficult, is what I'm saying, but I'm just wondering. It's an honest question. Like, why go through all that trouble and not just raise your API server and do end-to-end tests? Like, what's the benefit?
That's a good question. Then you start entering on the different types of tests, because on this scenario, me and my team were only responsible for the unit and integration tests. So the way that it worked on our team, we had the QA team that built the end-to-end process, and the end-to-end was their responsibility. So they were responsible for doing the entire flow of certain scenarios, and we did the smaller scenarios. So imagine in this scenario, the code, I'm saying scenario a lot, sorry. So imagine that on this part, on the code, you're only rendering a specific component. So you're doing a unit or integration test, depends on your definition of what it is. And on this specific part, the request is being fired just for that specific scenario. I'm saying English is not my native language, like Sarah said yesterday. But yeah, I think that's pretty much the benefit for us instead of just going full end-to-end. I have nothing against going full end-to-end. That's the thing. For us, it was came out of convenience for the process that we had. If for you think, okay, end-to-end is the way to go when we want to use end-to-end, go for it. But for us, for our scenario, I think this is one of the questions that the answer is, it depends on your team, on your perspective, on your processes. So I don't think I fully answered your question, or I gave you the one that you were probably expecting. But yeah, on this scenario, it's pretty much what the circumstances. Is there a question there? Go ahead.
I think we have final question from Naeem.
Thanks, mate, for the presentation.
Thank you.
A quick one. It is not. It doesn't have anything to do with your presentation. But at some point, you mentioned that you did GraphQL for REST. Do you
That-
remember the Do
yeah.
you remember the reasons?
I have no idea. But thank you.
Thanks.
All right, everybody. Thank you.
Thank you, everyone.
To Daniel, please. Thanks, Trevor. Thanks, Daniel. Okay, everybody. I think it's time for the second presentation of the evening. Mateusz Albuquerque is with us, and he's gonna chat to us about concurrent React. So, Mateusz, over to you.
Hello. Cool. I guess you can all hear me. I really hope the clicker won't trick me. So cool. Yeah, I'm Mateus. We're here to talk about Concurrent React. Before we move, this is me. I work for Medallia as a senior software engineer. I am a mentor at Tech Labs, Google Developer Expert in Performance, and you can find me pretty much everywhere as Y Combinator. And this is the QR code with the speaker deck for this session. So you can scan it and so that you don't miss anything. And if some part of the presentation sounds confusing, it's fine. Look for this emoji. It means it's a deep dive and we'll have deeper conversations after the talk. So just for me to have some context, who here is doing React, either at work, on side projects? Perfect. Try presenting this in like a conference with a vast majority with Angular and didn't quite work out. Cool. Just a little bit of a disclaimer before we move forward. Half of this presentation is a lot about design details of React and etc. And if something is a bit confusing, no worries. You don't need that most of the times to do React actually. And we'll look at some practical implications of the things we're going to be discussing. So cool. I'd like to propose a model exercise before we move forward. If you had to summarize Concurrent React in one word or expression, whatever, what would you say? For example, if I had to summarize fibers in React, I would say, okay, they're pretty much units of work that React uses internally. So, oops, 40 seconds. I want to hear from you. Concurrent React, random thoughts. Not everyone at once, of course. Async, confusing. Oh, it's not even counting. Thanks. Okay, first. Okay, async, confusing. Let's take one step back and talk about the main thread of the browser. So, clicker, work. So basically, let's say we have, for example, different kinds of inputs, checkboxes, or links, etc. If I virtually block that, you're going to see that everything stops working and the UI is not interactive. Why is that? Because of these long tasks. If you have profiled an app in the Chrome before, or whatever developer tools, you've probably seen those red flags, and you know they're tricky. So, okay, clicker, work. Yeah. Basically, they're the reason of some behavior like this. This is called rage clicking. It's basically when you click a button and it doesn't respond and you keep clicking until you see something, until you got some feedback. And not only this happens a lot out there, but there are even metrics like first input delay to measure that kind of stuff, or interaction to next paint, etc. So there's also a lot of research on the topic showing how bad that is. And for example, how even worse it is on mobile. So for example, for phone users, first input delay can be 7 times slower. Also, long tasks, they also delay the time to interactive. And in mobile, you can have 12 times longer long tasks. And there's even this number that on old device, like, or low-end devices, half of the time could be spent loading of the load time could be spent on long tasks. And things get real when you see how this impacts your actual numbers like conversion rates or other business metrics. So yeah, they're bad. So I guess the question we should ask in the first place, okay, what can we do to avoid long tasks? So that's when we start discussing task running strategies in the browser. So let's say we have A, B, C, and D, and we want to run them. We could parallelize that. So that would mean different cores at the same time, different CPU cores. We could go with concurrency. That is basically things are running in the same place, but you're quickly switching in between them so that it feels instant. And you could go with scheduling. That would be like concurrency, but you have this piece of software called a scheduler assigning different priorities to things and in charge of that based on some heuristics. So before we talk about concurrency, let's actually talk about parallelism. So first, we think of workers when we talk parallelism in the browser. But the thing about workers is that they're basically message passing, okay? But first, they don't have access to variable or code from outside the worker. So of course, that's why you need to message pass that. Also, they mostly don't have access to the DOM. So if you want to make DOM updates from a worker, that's really complex. And if you think about developing with workers, you have pretty much two models. You can think in terms of actors, or you can talk about shared memory. So in actors, if you've done backend development before with something like Bing, Erlang, Elixir, etc., actor is this abstraction that fully owns the data it is operating on. So they only send and react to messages in between them. And let's imagine in the browser that the main thread is the actor that owns the DOM and owns the UI it is operating on. In a web worker, we have the post method. So, but basically, post message has no understanding of request and response. So you kind of have to implement that if you want to do things that scale. And the end game here is you end up having to balance. You're moving your code to a worker to make that more optimized, but you have first the overhead of communication since you're copying things and to do the message passing thing. And also the worker might be busy and then you have to write code logic to handle that. Second thing would be shared memory. So it happens through the shared array buffer. That's an amazing API, one of the most interesting things. And the great thing here is that if you send a shared array buffer via post message, for example, the other end is going to get a handle to this exact same chunk of memory. So you're cutting part of the overhead here. But the tricky part comes to the fact that we're talking about JavaScript, we're talking about browsers, and they're just not built with concurrent access to data in mind. So you end up having to build a lot of structures for handling that kind of thing, like mutexes and etc. And the other thing is you're not doing arrays objects in the traditional JavaScript you're used to. You're doing bytes, series of bytes. And then you might think, okay, what about WebAssembly? WebAssembly is great, and it's actually, it's in my opinion, it's a perfect fit for the shared memory model. But first, a lot of front-enders are just not familiar, and they miss the comfort that you have from writing regular JavaScript. And the tricky thing when we talk WASM and performance, it tends to change in the future, but the tricky thing right now is WASM is really fast when you stay within WASM. But the more you cross the boundary and you start trying to manipulate DOM and that kind of stuff with WebAssembly, the slower it gets. And there are a lot of benchmarks showing, for example, that some of the fastest low-level implementations of web frameworks in WASM are sometimes outperformed by things like React, Inferno, or Solid. Before we move forward, I have to clarify that I do love workers, and there are a lot of great stuff on there are APIs like Atomics, and there are projects like Comlink and WorkerDon that they do address some of the problems I raised. But I guess that workers are really great when you have to do data processing, crunching numbers, huge mathematics, that kind of thing. But they're sometimes hard to use for UIs, and they could be harder than using, for example, a scheduler. So that's when we get to discuss concurrency and scheduling. And back to the question I asked in the very beginning, where we had async, confusing, etc. If I had to summarize in one question, concurrent React, that would be scheduling. So let's talk a little bit about scheduling in React. I'd like to approach the heuristics of the React scheduler and also what they call priority levels and render lanes. That those are implementation details, but they empower really good things. So first, the way React works is they don't have workers, they don't have parallelism. What they do have is a cooperative multitasking model where you have a single interruptible rendering thread. And this because of that, the rendering process can be interleaved with other tasks happening in the browser. And these other tasks could be, for example, other renders that React is performing. And that's why, for example, an update can happen in the background without blocking other stuff. It's easier when you can visualize. So let's say we have an original render task in React, and then I start typing something. So that's user input, and thus it has higher priority. So what happens is it moves to the higher priority render task, but then it can quickly resume the original one. And this is actually doing, so these are not happening at the same time, but the quickly switching, interleaving thing is where it happens. And you might ask, how does it happen? So it basically yields the execution back to the browser every 5 milliseconds. And I know that 5 sounds like a magic number, like the ones we use in CSS to fix something, but actually it's because it's smaller than a single frame, even if you're talking about 120 FPS devices. So that's why most of the time it feels interruptible. The other thing in the implementation are the different priority levels. So you see them defined in the source of the scheduler, and you see them repeated throughout the rest of the code, including in the reconciler, in the different React renders like React Done or React Native. And you see them even in React DevTools. And basically, those are different ways of React defining when it wants to perform something. And that can, though they have different timeouts assigned, and that means basically, okay, do that whenever you can, or do that now, etc. And the one last concept that empowers a lot of great things are the so-called render lanes. So basically, they are an abstraction built around the concept of bit masks. So one lane is assigned to one bit in a bit mask, and each update in React is assigned to exactly one lane. So that means that updates in the same lane, they can be batched together, and updates in different lanes, they happen separately. And the great thing is that this gives 31 levels of granularity to React, because that's how much you have in a bit mask, right? So the great thing here is that first, from a framework perspective, it allows React to choose when it wants to perform things, for example, split this in different batches or not. And also, it allows you to save a lot of things in the browser. So like multiple style recalculation, multiple layout passes, reflows, that kind of stuff. So that's a really interesting optimization. And usually when I see this kind of concepts in frameworks and etc., I'm always like, wow, this is mind blowing. But I can't stop thinking, like, there's a session by Kites and it's called "But You're Not Facebook." And I guess we tend to think, okay, I'm not the core maintainer of React. I'm not even checking the source code. So why would I care? I just want to write dashboards. So yeah, it comes a lot of the thinking, how do I benefit this of all of those interesting mad science in my projects? So that takes us to the next part, that is React for the rest of us. So I gathered 4 different categories of the whole concurrent mode umbrella thing where we can benefit. The first one is when we have to handle a lot of data. The second one is when we have to tackle wasted renders, so we're always optimizing apps and etc. The third one is about hydration, so mostly if you're doing SSR. And the fourth is like profiler, so we not only want to build apps, we want to debug them. So starting with large sets of data. it's crazy because we see a lot of examples that don't map to our reality out there. There's like some tutorials on how Concurrent React and this feature of React is so powerful and etc. And they're always like, okay, I'm gonna write a component that tries to find prime numbers, or I'm gonna run this heavy algorithm for cracking passwords, or I'm gonna render a fractal. Those are not things we're doing on a daily basis mostly. But things we are, for example, are rendering a lot of data points on a component. That could be something we do a lot. Or let's say we have to render something on a canvas, but we don't have off-screen canvas because of browser limitations. Or even things like processing a lot of data. We could be doing that. So here's an example of dashboard that you have this date span selector, and it filters records on the right using that. And you can see that the animation is a bit laggy, and it's not because I'm sharing the screen. It's because it's a lot of data to be re-rendered. I hope at least some of you can see the code, but there's not a lot of magic here. We have some internal state. We have an effect that's setting the initial state of the thing, and it's passed down to this component. And we have a non-change handler. And okay, you could say I could memorize some of the things like this handler, wrap it with a use callback. But there's something else I could do. That is wrap this with a transition that like those we have in React 18. So let's see the results. So it's way smoother. It might sound not a lot because I'm screen recording and etc., but it's way smoother. And actually, from a user perspective, it doesn't get laggy at any point of interaction. Oops, spoilers. And I myself, when I saw transitions, I couldn't stop thinking about cases in the past where I was, for example, I was working in this app about 5 years ago, and we had 100,000 data points plotted to a map. And the users should be able to search and filter in these data points. And back at the time, first we moved a lot of data processing to workers, but also we were using Redux Saga. So has anyone used Redux Saga? It's brilliant, right? One of my favorite Redux middlewares. So we had generators handling a lot of stuff, and also we were debouncing a lot of things. But it turns out that at the time, if we had better scheduling primitives, we could have used them like transitions. Another example, this one is more recent. It was about 3-4 years ago, and I was working on this game admin panel for a real-time game. So you should be able to moderate the real-time messaging of the app. So basically, I'm talking like few hundreds of messages all the time, and you should be able to search, to filter those messages, and etc. And at the time, we used a lot of virtualization with React Virtualized, and we were memoizing all the things to get a better performance. But again, we could have optimized that with transitions or a better scheduling primitives. The second case is tackling wasted renders. So have you ever seen this hook, use sync external store? 1, 2, 3, 4. Josh doesn't count. Okay. So the API is not quite complex. Actually, you have the subscribe method and a get snapshot and a get service snapshot if you're using server-side rendering. And this hook was initially sold as a hook for people building libraries, especially if you were building state management libraries. And it turns out that, for example, Redux started using it in version 8, and other libraries like Jotai and other solutions were also using it. But again, comes the question, how could I benefit from that? It's part of React. So one thing I bet many of you have used before is React Router, right? Cool. Let's assume all of you are using. So you probably know this hook, use location. And use location is really handy because it gives us a lot of things like the path name and the hash. But it's also an over-returning hook in the sense that it gives us a lot of things. So for example, in these two components, each component I'm using just one part of use location. What happens is this is using the React profiler. So you can see that I'm clicking things and I'm changing only the hash of my site, but the path name is re-rendering as well because I'm using that hook. So how could I change this? I could, for example, build my use history selector hook that is under the hood using usesync external store, and use that at a later point in time by passing the location path name or the location hash. And the result is that now the only component that's re-rendering is the hash one and not the path name as we want. Third thing are hydration improvements. So who here does SSR, by the way, with Next or whatever? Okay, about 10 people. So hydration in React used to happen for a lot of time like this. So you're fetching the data on the server, and then you render the HTML. You shoot the HTML to the client. That's when you get your first byte. And then you're loading the code on the client, and that's when you get your FCP or your first paint. And only then that you process all the JS and etc. is when you hydrate things and it becomes interactive. Thing is, that's bad because hydration could only begin after the whole thing was fetched, and basically the users can't interact if it hasn't been hydrated. So the final result here is that you have the fast pages, the fast components of the app having to wait for the slow ones. This changed when they introduced this new suspense SSR architecture in 18 that is basically combining stream SSR, that is one of the most overlooked things that happened in React 16, because React 16 gave us the streaming SSR, but we were busy talking about hooks and other stuff. But with React 18, we got something that is combining stream SSR with selective hydration. So basically, this allows us to go from this to this, which is not blocking and sequential, and allows us to get all of those before. So it's done basically using this new API, pipe to node stream, and create root and suspense on the client. And the thing is that React, by using the concurrent umbrella of things, it prioritizes hydrating the parts of the app that the user interacted with before the rest. And also because of this, React no longer has to wait for the huge parts of the app to push the fast ones. And also, when that one chunk is ready, it throws this, it renders as a script tag, and it's inserted in the right place. There's a lot of case studies out there. Actually, Versal, for example, they optimized the Next.js website by using selective hydration and streaming SSR under the concurrent mode. And they got like better first input delay and interaction to next paint, which is the new cool metric out there. Last but not least, we not only want to build apps, we also want to be able to properly debug them. So there are also profile enhancements. So we discussed the transitions, for example, and you might be thinking, okay, how can I debug a transition? So there's this new scheduling tab, and you can debug transitions. And my favorite part is actually this. So now you have those tricky hints that basically the profiler detects, okay, this is a long task. This could potentially be moved to a transition. And they say, okay, move that to a transition. So those hints are really helpful. That's present, and that was a lot. But there's even more coming down the line. So we're going to have more and more I/O stuff like React Fetch. We're going to have more things like the cache component for data fetching libraries to integrate with suspense. We're going to have suspense for CPU-bound trees. That's really interesting. For example, suspense is meant mostly for I/O-bound parts of your tree, for networking and those same kind of stuff. Suspense for CPU-bound basically means if you know that this part of your tree is going to take a lot to render, you can suspend right away and not try to render that. We're going to have more and more hooks for library maintainers, like use insertion effects for style sheet libraries. The offstream component, which is also amazing, is basically a declarative way of flagging something that you want to postpone. We have already / gonna have in the future server components which deserve multiple talks on their own. And we're gonna have native scheduling primitives on the browser. That is amazing. So have you ever seen this? It's prioritized task scheduling API. And it's not only an API, it's actually an umbrella of different APIs that is basically a more robust solution for scheduling than what we have nowadays. Like if we think scheduling, we have set timeouts that or set interval or request animation frame. Those are the primitives that the web gives us. Like we have microtasks. The scheduling umbrella is going to be a way more powerful promise-based way of doing this and integrated directly into the event loop of the browser. And it's aligned with different core teams. So the core team of React, Google, the DoubleTree Consortium, and others. These are 4 examples, but there are even more APIs under this. We have post task, for example, that is as the name suggests, a way of scheduling things with different priorities associated, like whether something is user blocking or whether something can wait. We have yield, that is a way of yielding execution back to the main thread without having to rely on workarounds with generators, for example. There's interesting stuff like is input pending. That is a way to detect if the browser is busy processing some user blocking thing like an input field. And a lot of companies are actually using some of this. Facebook was the creator of is input pending, and they use that in some parts of their stuff. Airbnb has a really interesting case study of optimizing some of the things they had with post task API. And there's even open source stuff like this main thread scheduling that is built around the spec. It's not a polyfill, but it takes a lot of inspiration from the spec. Finally, that was a lot. But a few closing notes. I love this session by Rich Harris. Actually, I love a lot of sessions. Rich Harris is the guy behind Svelte, and he has a session called Rethinking Reactivity. And he presented in 2019, and he explains a lot of how React works under the hood and etc. And in this session, he makes a really good point on how React is not reactive. And he is right, it is not reactive, but it is concurrent, and that might be enough for your case. Another quote is by Guillermo Rauch, the CEO of Versal. This quote is from back at the time it was Zeit, and he said that React was such a good idea that we would spend the rest of the decade exploring its implications and applications. And I think a really good example of that is this scheduling API that had a lot of influence of React and many other APIs and discussions, actually. If you check on the time, if you go back in time, you'll see, for example, Sebastian Mockbach suggesting things to the core of JavaScript 7 years ago. So React has pushing a lot web APIs. Have you seen this RFC? It was like a hot topic in the community back in November last year. It's called First Class Support for Promises. Basically, it's also called this new use hook. So yeah, if you say like this, then probably people know, because so basically uses this new special hook that they were willing to introduce that couldn't miss some of the rules of the hooks. And it's really powerful. Reason why I'm mentioning is this is an example. You don't have to bother reading it, but the point is it's like a 40 lines of code example of implementing a custom cache solution and throwing promises that can be caught by suspense. So this is use promise that it's pretty much imitating the use hook from the proposal. And the point I'm trying to make is, did we create something similar to React use? Yes, we did. And I think that understanding those internals we discussed about 10 minutes ago, like the boring parts, is really interesting because they basically empower us to build our own abstractions on top of them. So understanding the rationales behind some of the things, like why suspense works by throwing a promise, or the whole thing of render lanes, etc. That empowers us a lot. The fourth thing is scheduling is great, but it's not a silver bullet. So it has its downsides just like anything else. And that's why it's important to remember the cliche that there's no silver bullet. Identify your core metrics. Like people talk a lot about a lot of cool technologies on Twitter a lot of the time. And it's important for you to check your metrics and to experiment and figure out what actually works for you. Yeah, that's the point I was making. There's a lot of information. You see core committers of different libraries, really respected people making really good points, and some of those points are sometimes going one against the other, and it's easy to feel lost amongst this whole realm of information. So yes, always correlate the performance technologies of the optimizations you're playing with, etc., with your business metrics, with your conversion rates or whatever business metrics matter for you, because that's what matters most in the end. That's all I had. I think it's Faristos. I hope so. I think we have time for questions. Thank you, Faristos.
Great talk. Thanks, man.
Thank you.
Questions? Everyone is still parsing. Everyone is still.
Is that blowing hand thing? Right? You wanna have the mic?
Yeah, I don't know what I want to ask.
Okay.
Have a think, and we'll figure it out.
The thing in the very beginning where I have the emoji of the scuba diving, that was for some of the conferences I used the emoji of a beer, which means like you need time to process, and then we can discuss that over a beer or coffee. So take your time. I'm gonna be around for a while, but let's discuss.
Oh, there we go.
Hello.
Hi.
I am not familiar with React. I just want to ask you because you are more experienced. Okay, the minimum. About the next 5 years and a lot of new libraries of JS that coming up the last 1-2 years. Are you going to stay with React and continue in parallel with other JavaScript libraries?
That is a really good question. So I think it's crazy because in 2016 we were discussing a lot about the JavaScript fatigue, and back then we only had to choose between React, Vue, and Angular. And I think that nowadays we have a whole other spectrum of things we can choose from. I think I will keep betting on React for. It's funny. I have a session on this topic. By the way, it's 40 minutes, so I can link that to you. But I think I'll keep betting on React for a lot of things. But I always like to keep an eye on what's happening outside, especially because that's kind of spoilers of the other session. But basically, you see that a lot of things in software engineering, they cycle back to what they were before. So React server components, for example, the big thing happening in React since 2020, and that's more exposed now that we have the app director, the app router in X13. They get a lot of inspiration from, if you compare the code snippet, it will look a lot to something that's called Jaxer that was built on top of jQuery, and that was being done in 2008, more than a decade ago. And the same things, like we're discussing Astro and the whole idea of islands. We got the name islands in 2020, but the idea behind islands of progressively enhancing things, people were doing this in 2013 with ViewLoader.js. So the whole point I'm trying to make is a lot of ideas will keep cycling back. And React, I guess that React will be aware of some of those, and it will be getting inspiration. If not React, the whole bunch of meta frameworks we have around it. For example, Remix did something brilliant throughout the years. They were basically building server components, but without the help from Vercel. Vercel was lucky because they were more aligned to React. So I think that a lot of things will keep cycling back. Better ideas like resumability in Quick will pop. Perhaps React will get them, perhaps it won't. It's funny you asked because I have this, one of my last slides that I kind of cut from this presentation is basically me in almost 9 years ago. I was presenting in the iOS developers meetup, and I literally approached them and said, hey guys, you know what? Angular and Ionic are the future. You should stop writing native apps. So it's really hard to come up with those speculations and future predictions. But yeah, yeah, I'm not sure if that clarified or made things, or if I went that really tangent, but
Thank you. Oh, no. If there is 1, 2 libraries that you could separate that are more fast for developing and publish your new app.
ooh.
If there is something with more simple life cycle, more simple developing, more simple development. Sorry. Out of scope question. We can
Yeah, I
answer
wouldn't.
later.
For example, I wouldn't say Svelte because I'm the JSX guy, so I would say solid. But no, but not Jones. But but that's really tricky. That involves a lot of context. I wouldn't trust. If I were you, I wouldn't trust myself if I said I had an answer. Like so, but if you have an app in mind, let's grab a beer and we can discuss. But it really depends. There's one thing. There's this thing called application holotypes. Google it. It's a post by Jason Miller in the year of 2020, where basically he was trying to trace all the possible kinds of applications you might build. Okay, like a social network or a media player or a game, etc. And he was going through strategies that made sense for each type of app. Ryan Carniato, the author of SolidJS, years later, he extended that where he would go, okay, for this kind of app, that's how I would do rendering. That's how I would do hydration. That's how I would do server-side rendering. I think that's the thing you might be looking. Like, get the type of app you're thinking about, and split the different aspects of it, routing, etc., and then you'll find eventually something that will fit. But applications holotypes is what you're looking for.
An amazing talk, Mateus. Thank you ever so much.
Thank you.
Hello. Okay, let's start. I'm this guy right here. I'm Naim. I'm an associate director of engineering at GWI, and we are going to have a quick look of our journey so far around microfrontends in GWI. Why microfrontends? You have the ability to scale your code base easily. A single team can own a specific part of the whole platform. You reduce the risk of using a single new front-end technology that comes up every day, and this can be contained in a single part of your application. It establishes a cadence of deployments for each team, and also ensures that the teams are not dependent with each other. And last but not least, there is an engineering calculator, an MFE calculator, micro front-end calculator, in which you can add, let's say, you can answer quite a few questions on how big is your app, how many people are in your team, blah, blah, blah. And it says to you if it actually makes sense to go with micro frontends or not. Our journey in GWI started in 2019 around micro frontends, and neither the team nor the community had any experience with it, and didn't and wasn't even aware of all the bottlenecks and problems and stuff that come up due to micro frontend implementation back then. Today, we are going to discuss only the problems we have faced, because everyone can argue that micro frontends is the best architecture out there, but it doesn't make so much sense to us, rather than discussing the problems and how we overcome those problems in the past. So problem number one, and what we have also talked about in CityJS, it's the micro frontend versioning. Long story short, we wanted in GWI, and in general we want to have a new version of a micro frontend updated, but we don't want to fully update it to update it fully automatically. And also, we don't want to update it fully manually. So we have to find kind of a balance in there. The solution that we have given to that is that we have created an internal service. This service, we called it front-end configuration. This is also tied with a simple UI. And actually, we enabled all the engineers in ZWI to create their own micro-frontend applications using this solution. And actually, it's so simple that also designers or PMs can use this solution too. You can find quite a few details on the hyperlink. Actually, the presentation is going to be shared anyway, and you can have a look on the details there. The second problem that we had, and we never actually overcome this problem, is having a single design system. So if there isn't a single design system in place, there wasn't a single design system in place. The reason for that was that we had both Elm and React micro-frontends. So that meant that we had two design systems in place, which created quite a few issues for us. Those issues were that it was really hard to detect UI mismatches between micro-frontends and also the designers, because they belong to different teams. It was quite hard for them to spot the differences. In addition, all the changes that were made to the design system from the designers was not really easy for us to bubble the changes directly to all the micro-frontends, because as we said, we had two different types of micro-frontends. The first one was Elm, second one was React. And the third and fourth, actually, I have those two together in my mind, was that we needed actually a huge effort to update both our UI libraries and to be consistent across all the micro-frontends. We never really ever overcome this problem, and it was one of the main reasons that we decided to actually ditch Elm and proceed only with React. There were quite a few issues too that I'm also going to address down the line, but this one was one of the main reasons that we decided to ditch Elm. Problem number 3, one of the additional reasons. So what we did, how we started implementing our platform, our application, is having very vertical slicing, meaning that everything in our application that was an item on the menu bar was essentially a micro-frontend for itself. However, at some point, we needed quite a few stuff to be shared across micro-frontends. And what was the solution to that? Unfortunately, was having common stuff implemented as web components. Again, this was not quite a good solution. It was a solution which was not helping the maintenance of the code base. And the way that we implemented that was essentially what can maybe seen by the image on the right. Essentially, what we did is that because we have implemented most parts of the front end in React, we extracted the stuff that needed to be shared across micro-frontends. We built them down to HTML elements using web component wrappers, and we shared those web components both in React and in Elm world. Except the problems that I just referred to, there were some additional ones. So once we found the solution of using web components, there were some problems to that too. So the first one was that we didn't have component versioning in place, meaning that we just shared Git hashes, which is not a very good way to communicate between teams, and we didn't have a clue of what was going on. And due to the fact that we use React with TypeScript, at compile time, we didn't have the TypeScript compiler error prevention, which could assist a lot in our case. So what we did, as a solution to the solution, we decided to implement at last a Semver implementation, semantic versioning, meaning that we had major, minor, and patches for our web components. We established communication between component and micro-frontends by utilizing browser custom events for the output and HTML attributes for the input. And if we wanted to actually pass something pretty complex, we passed stringified JSONs. Don't try this at home. It's not really good. And last but not least, we stored the web components in an internal storybook for everyone, meaning designers, PMs, and us developers to actually implement the stuff. we had the storybook, an internal storybook for everyone to review. Problem number 4. The problem number 4 was creating a single page mini application. So we had a feature where we wanted to have a single page app, but its domain was pretty complex, meaning that it didn't make sense to have this in a microfrontend of itself, but it also didn't make much sense to have it as a web component because its implementation was really complex. So what we decided to do was create a pattern of our own, which didn't exist because, as we said, it was kind of like a greenfield back in 2019, the world of microfrontends. So what the black box pattern was essentially was a function. You can imagine it as a function which has some inputs and produces some outputs. The communication with it can be done through browser custom events. And the additional part that we did was tie the function, this function that I talked about, with UI. How this worked, we have made a blog post out of it. And it actually worked pretty well for 20-something years, which meant that it was quite a good solution. But when the time came for the Elm guys to actually consume this thing, they had a problem. Why the problem existed was the fact that the guys wanted to actually consume it as a web component, meaning that all the effort that we have done as for the whole functionality to be working as a black box was just translated to a web component so that they were able to actually consume it. Last but not least, certainly not least, micro-frontend communication. So this is the final problem actually for today, and we managed to have our app working for 2.5 years without having the micro-frontends interact with each other at all, because we thought that if we made such functionality, then we will open the Pandora's box and all the hell will break loose and we will all lose our jobs, you know, all this kind of doom stuff. So what we did back then, actually this was a year ago, we decided to actually make the micro-frontends communicate with each other because there were quite a few features that needed to be implemented and we just couldn't ignore this anymore. And we decided to have a shared state between our micro-frontends. In addition, what we did is make the host essentially is the app that all the micro-frontends go and sit upon. What we did is make this host also a service bus. So essentially what we do is pass the shared state from a micro-frontend to another, but we had made the agreement and the contract that we are not going to overuse it. And for a year now, this has worked pretty well, strangely enough. Some future stuff. We want to use module federation. Up to now, we have used single SPA, and it has worked quite well, but module federation solves quite a few issues that we still have them, and it's going to be quite a benefit for us. Apart from that, due to the fact that we want to move from Git flow strategy to trunk-based development in some of our teams, we decided to also support this, our front-end configuration, because we also have to support stuff like feature branches or whatever. And last but not least, we want to merge together all our common components in a single repo, because right now, the way that this thing has been implemented is create quite a few features in quite a few repositories, and there are many interdependencies between those repositories, meaning that every time we update a version on the leaf of the dependencies, we then have to create cascading dependencies all up to the tree, up to the micro-frontend level, meaning that this creates quite a few issues for us. It slows us down, our velocity, and things like that. So that could be everything. Really fast. It was really late. Thanks a lot.
Thank you, Naeem. That's a great talk, and indeed very fast. Thank you for that. We do have time for a few questions. If anybody has one, can I just ask, man, how hard is it to hire an Elm developer in Greece in 2023? Seriously.
This actually can happen. One of the other reasons that we decided to move with React only.
Hi.
Hello.
Yes, thank you for the presentation. I want to ask you how you managed to what you used to use the same state for both technologies.
Okay, so the way that shared state works at the moment.
Because I'm doing something similar. I'm using React on one end and Knockout on the other end.
Okay, interesting.
Yeah, I know. So I had a similar problem with state.
Okay, what you can do is utilize custom browser events and make. Are you also using kernel, a host, or you just have interaction between the two apps?
Yeah, I have some interaction between two apps.
Okay, in that case, there is a library that can help you. And what this does essentially is share the state using JSON objects. And the first, essentially, it's publish subscribe pattern. And what it does is essentially you say that I'm the publisher, the other app is the subscriber, and it could also work vice versa for two-way communication. And what you can do there is just publish and subscribe to events, passing those objects. Okay. But I can also show you a library after the presentation finishes.
Another question?
Thank you very much for the presentation. I have started experimenting with Microfrontend the last few months, and I have faced the following problem. I use, for the host application, I use a Next.js application, and the routing is based on the folder.
So it's a monorepo. You have a host, and on parallel folders.
And multiple micro-frontend applications.
Okay.
So I wanted to have the routing split in multiple micro-frontends. Mm-hmm. So I was trying to include some routes from the host, some routes from another application, blah, 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 blah. But I couldn't do it, so I just had all the routes on my host and just the components on the micro-frontends. So
right.
How have you managed to do something like this, if you have done something like this? So, or maybe is it an anti-pattern, the thing that I was trying to do, to include multiple routes from each application? Is it a good idea, or?
It's not so a good idea, but it can work with some patterns. What we did in GWI is having the first layer of routing delivered, let's say, by host, meaning that due to the fact that we have vertical slicing, meaning that each micro-frontend essentially is an app of its own, what we do is we click on the top menu bar, and what the host does then is route to this app. So, for instance, the top level bar is, upon click, it's going to route you to a new app. And from that point on, from the second layer onwards, all the routing is handled by the micro-frontend itself. So the host is responsible for the first level of routing, and everything from that point on is handled by its micro-frontend.
Okay.
Does it make sense?
Yeah, okay, I got it, but it was not exactly what I was trying to do, but okay, this can support
this is a little bit cleaner and it can actually alleviate you of quite a lot of pain, because this is quite straightforward, having the top level handled by host and everything else handled by...
Okay, thank you. And one more question, if when it's time to host the application on a server, is there a way to to make the microfrontend applications to speak with each other, to communicate without the browser? Just if we have them in the same server, can we include, or I think you got
How
the
are
question.
you running your applications, though?
Sorry?
How are you running your applications? Are there Node.js applications?
Yeah. You just hit start, but I want to include the remote JS, let's say, not in the browser to see the JS imported, just internally like an SSR, let's say. Is there a way? I was trying to, but I didn't find anything.
I'm not sure. I'm not sure
neither
this is.
ChatGPT told me the idea. So
I can guess. So I think actually everything can be done, but again, I think that this may be an anti-pattern, and how we handled it is again having the host as a service bus, because it's pretty possible that the microfrontend in our case isn't even loaded, so the data has to stay somewhere before we fetch the microfrontend, so that we pass the data
because
to
of the state management that you said.
Exactly.
Okay.
Exactly.
Okay. Thank you.
Hello, thank you for the nice talk. I know everyone wants to go by this point, so I'm going to keep it very brief. So now that you've gone through this journey and you have dabbled and been working with microfrontends, would you say that you've been satisfied with it? Is it something you would do again? Or is it the case that since now we have Next.js that does all this sorting and breaking things into smaller packages,
Don't
you
try
would
this
go
at
with that?
home.
Yeah, I guess that's my question. Are you happy with it? Would you do it again?
It depends. For GWI, certainly, yeah. And for even my previous role, probably again, I would do it. It depends on the scale. Do you remember the calculator at the start of the presentation?
I was one of those that were late, but
Okay, just a sec. Actually, it doesn't say anything. It's just a hyperlink. So there is a calculator. If you click here, no? Come on. Yeah, if you click there on the blue thingy, there is a calculator where you input how many people are in your team, how big is the application, how many line of codes do you believe that it will be, blah, blah, blah. And it returns you a percentage of how possible it is that microfrontend will actually be an assistant and not a burden, in your development.
lovely. Thank you.
Ευχαριστούμε πολύ, Naim.